Have you ever had to make a tough decision? One where the stakes are high, there's trade-offs and no clear best option? And what about situations where there's a group of multiple decision makers all with different perspectives? This can make a tough decision even harder yet again. Tough decisions are characterized by multiple objectives, multiple stakeholders, uncertain outcomes, incomplete data, significant impacts, and intangible outcomes that are hard to quantify or monetize. The chances are you're currently working through a few tough decisions right now for your organisation or for yourself. Decision points are critical times in the lives of organisations and individuals. When you're at a decision point, you'll want to invest as much as possible into making the right choice. The option you choose can make or break your organisation or career. It can be pretty stressful sometimes. Fortunately, there's help at hand. The field of decision theory has emerged over hundreds of years to help people make wiser choices. Today it falls under the disciplines of management science, operations research, psychology, and economics. And one of the most widely applied and useful tools in the decision theory toolkit is Multiple Criteria Decision Analysis, or MCDA. It's probably easiest to explain with an example. Meet the Smith family. They're a family of 4 and they need to buy a house in their new city. And they've found some pretty good options. A small inner city 3-bed 2-bath townhouse close to everything with tiny garden but a vibrant neighbourhood. A family-sized 4-bed 2-bath house with a functional garden and carport and an average commute. And a large 5-bed 3-bath house on the city fringe on acreage but with a big commute. It's great to have options, but now we need to choose. And for that, we'll need criteria. The family got together for a conference and after much debate came up with several criteria. This is what matters to them most when they buy the house. The criteria include distance to the city centre in kilometres, less is better. Size of house in square metres, more is better. Size of garden in square metres, more is better. And the cost in dollars, less is better. That's great. We can now build an evaluation matrix with the options as rows, the criteria as columns, and all the performance metrics in the table. As with most decision problems, the criteria aren't all of equal importance to our decision makers. So we spend some time with them and find out the most important thing is distance to the city centre. And the least important thing, although still matters, is the size of the garden, with the other criteria somewhere in between. Now you probably know you can't add apples and oranges. And we can't add or combine the performance data in different units. This means we'll need to use transformation functions which turn the raw units into commensurate scales from 0, which equals worst performance on the criterion, to 1, which equals best performance. In this example, we'll do a basic linear stretch based on the distance to the maximum or minimum. That creates a table that looks like this. Next, we adjust for the weights. We'll simply do that here by multiplying the weight by the transformed performance score. Lastly, we'll simply add the weight-adjusted scores to get an overall score for each house. From this analysis, we can see that the winning house is the smaller inner-city option with a courtyard. The country house with acreage is a close second. But the heavy weight assigned to the criteria on distance to the city centre won out. So this family is going to sacrifice space for the convenience of an inner-city lifestyle. But we've made some simplifications here. Let's explore how we could improve this model if we were doing it for real. We've used simple linear transformations. In reality, there might be critical thresholds where the house is just too small to be considered, or the cost too high. And they might not have a simple linear more is better or worse relationship. It could be convex, concave, parabolic, or many other shapes. In a real MCDA model, we'd put a lot more effort into the transformation functions. Secondly, we've clearly not identified all the criteria that probably matter. The number of bedrooms, the number of bathrooms, the proximity to schools, whether the house looks good, and a long list. In real applications, we'll often build out a large and complex decision criteria hierarchy that comprehensively models the decision problem. Thirdly, we glossed over the weighting stage. In real applications of MCDA, this is challenging. We might have lots of decision makers, and a simple average might not be a good representation of their preferences. They might also struggle to give us percentages, so getting weights from decision makers is a challenging task. Fourthly, we didn't do any sensitivity analysis. In real MCDA models, we'll often put error margins around all input parameters and rerun the model thousands or even millions of times to see how the results change and whether they're stable. One of the most common methods used is called Monte Carlo simulation, after the famous gambling town in Monaco. Fifthly, we didn't pay much attention to the process of choosing the options or the criteria, or how the final decision was actually made. This is probably the hardest part. We call it problem structuring. A real MCDA analysis typically takes quite some time to determine the options and the criteria. And when we see the options, we often want to change the criteria and vice versa. And lastly, an MCDA model is never 100% accurate. There's always matters above and beyond the model we didn't account for. These somehow need to be melded with a real decision maker. There's many more ways we can improve this MCDA. There's over 100 different techniques of MCDA and numerous guidebooks on all aspects of MCDA methodology. Glossing over these and other such critical methodological considerations can lead to problems. MCDA is a powerful tool that can improve the analytic rigor of decision making. But when the stakes are high, it's important to invest sufficiently in all aspects of its application. Over the past few decades, there have been thousands of published studies on the use of MCDA in practically every industry sector and social sphere. At CSIRO, scientists have used MCDA widely within Australia. Here, two of the lead scientists, Dr. Stefan Hajkowicz and Dr. Alexandra Bratanova, talk about MCDA applications they've worked on to help decision makers in large and small organisations make wiser choices.
So I think multi-criteria decision making improves the analytic rigor of decisions. It gives you structure and it brings data into decision making. It improves the auditability of decisions so that we can audit a decision once taken and we can understand why decision makers have gone down that path. It helps you learn about trade-offs inherent in any complex decision problem.
The MCA was applied to help decision makers prioritize trade. It allows decision makers to combine their thoughts, their expertise, their knowledge across the different fields into a well-established list of priorities, which is very complex when it comes to fields like mining or energy or health, where the stakes are very high. The MCA model was constructed through a series of workshops. We had a lot of stakeholders engaged in the open conversations online, and the MCA allowed us to come up with a clearly defined set of priorities, what to do, how to do it.
So I first started using multi-criteria decision analysis in my PhD at the University of Queensland, where I contrasted and compared decision-making via intuition, gut feel, with rational and structured approaches like multi-criteria decision-making to looking at the differences in decision-making styles. Both were quite important in decision-making, but MCDA certainly helps provide a structure for sound and good decision-making.
In this project, MCA was the core to the decision process. It allowed people from very different backgrounds and very different expertise to come up with a joint solution to the problem, and also to show the priorities in a way that's transparent, clear, and established.
In every single project on MCA that I've worked on, we've still found that decision makers have a really important role after the analysis is finished, and oftentimes they may even change the result of that decision a little. So we need to always be respectful of the human decision maker and the human decision making process that sits above our model. It continues, I think, to be quite a powerful tool for decision making.
So that's the short story of MCDA. To find out more or engage the CSIRO research team to help you with your own MCDA model, please get in touch.